lesson 2 looks at compound interest and present value, and it's a little bit different than what you saw in lesson 1. Lesson 1 looked only at simple interest, and simple interest means that you are only earning interest on the principal amount that you invested. Whereas in compound interest, you actually end up earning more interest over time, and the reason for that is because you earn interest on the principal amount that you invest, as well as any interest that you've accumulated over time as well. So basically in compound interest, you get to earn interest on interest. Okay? So number 1, if we look at the warm-up, says write the general formula that represents exponential growth. And now the reason why I'm looking at exponential growth in this case is because in compound interest, you're earning on previously earned interest as well, and so it ends up creating an exponential growth in your investment. Okay, so the equation for exponential growth that we know from before is y equals a times b to the exponent x. And just to remind you what each of these variables represent, a represented the initial amount, b represents the exponential growth or decay, and in this case, because we're looking at an investment, your money will be growing over time, so we're going to be looking at an exponential growth. And x represents a number of growth periods or decay periods. Like I said before, we're only going to be looking at growth in investments, so it'll be the number of exponential growth periods. Okay, so looking at question number 2, it says Sazia invests $800 at 6% interest compounded annually, and determine the interest she earns after 1 year. So she's earning 6% interest. It's compounded annually, so she's going to earn the interest once in a year. So if I find 6% of $800, so 6% as a decimal would be 0.06. And if I try to find 6% of 800, I get $48. So the amount of interest she earns in 1 year is $48. Okay? Alright, so part B says determine the accumulated amount after 1 year. So if she earned $48 in interest at the end of the year, and she had already invested $800, then that means in total she should have $800 plus the $48 that she invested, which would be $848. Okay, so at the end of 1 year, she should have $848. Now in part C, it says determine the accumulated amount after 2 years. Now, because she's earning interest on interest, and that's what compound interest is all about, what that means is in the second year that she's invested her money, she's actually going to earn interest on the $848. So what that means is in her second year of her investment, she's earning interest, or she's earning 6% interest on $848. So I actually have to calculate 6% of $848. And so if I use my calculator to do that, 6% of $848 is $50.88. And so if you compare how much interest she earned in her first year versus in her second year, you'll notice that she's earned an extra $2.88. Well, where did that extra money come from? Well, it came from the fact that in her second year of her investment, she's actually earning interest on interest. So she only put in $800 in her account. That extra $48 that she earned in interest after the first year is what she's actually building more interest on, and so she's making more interest in the second year than she did in the first year. So her accumulated amount would be $848, which is how much she has at the end of the second year, at the end of the first year, sorry, plus the interest that she earned by the end of the second year. And so in total she will have $898.88. So that's quite a bit of money. You'll notice that it's slightly more than it would have been if it was simple interest, and that's because she's earned interest on interest. So in her second year, she's actually earned more in interest. Now, if I try to come up with an exponential equation to model this data instead, what you'll notice is that I can rewrite this equation using variables that we saw in lesson 1. A representing the accumulated amount she makes over time. A is our little a is our initial value, so I can use P as our principal amount, which is the amount of money we invest initially. B would be our exponential growth or decay. So in this case, what that means is she's invested $800 $800 at 6% interest. Now let me just replace P with the $800 since I know what the initial investment is. And so my growth ratio would be 1 plus the growth rate. And so the growth rate in this case is 6%. And so 6% as a decimal is 0.06. So essentially I'm going to be adding 1 plus 0.06 to get 1.06. And the exponent I have is the amount of time that I'm investing for over the span of however many years I decide to invest for. Okay? And so if I actually use this formula to try to solve for the accumulated amounts after 1 year or the accumulated amount after 2 years, I should get the same answers that I had when I just did it the long way. So let's see what happens if I try to figure out the accumulated amounts after 1 year and see if our formula makes sense. And so if I do 800 times 1.06 to the exponent 1, I get exactly $848. And so this is how much money she would have in her account at the end of 1 year. Okay, so that's actually sort of an intro to what your compound interest formula is going to look like. And we'll talk about that some more in a few minutes. If I wanted to see if it makes sense after 2 years, so if I go back to the original equation and I replace t with 2 to see what happens after 2 years, I get 800 times 1.06 to the exponent 2, and I get $898.88. And if I look at how much money she would have at the end of 2 years, she has the exact same amount. So what this tells me is that compound interest represents an exponential growth in the amount of the investment. And so it depends on how much interest you're earning and how often you're earning that interest, and we'll talk about that in a few minutes as well. And it also talks about how much you invested initially, so your principal amount. So we'll look at all of that when we look at compound interest.